All right, so how to make a graph, and we'll call this one here Graphing Basics. So we need to make sure that we decide which variable to put on the axes. So the independent variable goes on the x-axis, right? Your x-axis is going to be your horizontal axis, and your dependent variable is going to go on your y-axis, and your y-axis will be your vertical axis. So then you'll need to make a scale for each axis by counting the boxes, which will be the spacing to fit your largest value. Write the numbers evenly spaced from the origin to the range maximum. So each box, in this case, each box here, if this is 0 and this is 5, I've got 1, 2, 3, 4, and 5. Each box here is one unit of measurement. Where here, it's 0 to 100, I've got 5 marks in here. Each box represents a size of 20 or a magnitude of 20. Where here, I've got a 0 to 200 range. Notice that these are all the same spacing. It just depends on, well, what is each box going to be represented by? And here it's a value of 40. So we can have, just depending on what we're measuring or what the size of our range maximum is, it's going to determine what the spacing, what each box is going to represent. So plot each data point using dots for each of the x, y coordinates. Connect the dots. Sometimes one looks for trends using what's called a best fit line. And I'll do that when I demonstrate this here in just a few moments. And then you'll create a title and write a summary statement on or near the graph. A graph is a picture that shows how two variables are related. Graphs are easier to read than tables of numbers, so they are often used to display data collected during an experiment. So let's see if we can do that here. Let's see if we can look at a graph and make sense of it. So let's read a graph. So I'm going to start off by working the same things we did on the first page, and we're going to work backwards. So I have a title here, and now I'm going to look at my axes. So this is a position time graph. Time is on my x-axis. This is my independent variable, and position is on my y-axis, right, my vertical axis, and this is my dependent variable. And essentially, this is called a position versus time graph. And what I can do is I can plot these points, and this was a graph that's provided. So let's familiarize ourselves with the graph, reading a graph. It is important to read the title to get an idea of what the graph is intending to show. 2, identify the units of measurement on the graph on the axes. Right here, this is in kilometers, and this is in hours. On a distance time graph or a position time graph, and distance time graph will be the same as position time graph, we're just calling it something different. Be sure to be able to interpret numbers as to what motion is taking place on the graph. For example, what is taking place on the graph for the 3 motions? Well, notice, so we got to do some interpreting here. So if I look at this, if I look at these, if I call this section right here section 1, and call this one here section 2, and this last change of kind of motion, call that section 3, I can see that this object here traveled, right, I'm looking into the numbers here, 180 kilometers in 3 hours, right, for section 1. Section 2, the object stopped. It traveled no distance in 1 hour. And then for section 3 here, or segment 3, it traveled from 180 kilometers to 580 kilometers for a distance of, or a position of 400 kilometers, and it traveled 400 kilometers in 4 hours. So we're moving pretty aggressively, but you'll get the hang of it. So what is the speed for each section of the graph? Well, this one here traveled 180 kilometers in 3 hours, right? 3 hours. So it traveled 60 kilometers per hour. This one was stopped. It was traveling 0 kilometers per hour. And the last one traveled 400 kilometers in 4 hours for a speed, in this case, a rate of motion of 100 kilometers per hour. And what is the average speed for the entire object's motion? Well, here I can look at the total placement, the total distance traveled here. And if I look at this, you'll see it traveled 580 kilometers. And I can divide that by 8 hours, and I would see that it traveled for an average, in this case, an average speed of 72.5 kilometers per hour. And last but never least, a couple of general reminders. The steeper the slope, the greater the speed. So notice car A has a steeper slope than car B. Car A was traveling at a greater rate, in this case was traveling at a faster speed. The slope of a distance time graph, or in this case a position time graph, which we can use synonymously, the same as, the slope is the speed of the object. If there is no slope, there is no speed. So it's traveling at 0, in this case, would be meters per second. The object is stopped, or what we will call in physics, at rest. Here we're going to look at what's distance and displacement. They are not the same thing. For example, a student moves 100 meters from a starting location. The student then turns and walks back 50 meters from where he or she left from. The total distance traveled is 150 meters. Right? That's a distance of 150 meters. That's the total number of meters that the student walked. But the net displacement is only 50 meters. The student ended up only 50 meters away from where he or she began. So therefore the net displacement is relative to the starting location. Distance continues increasing while displacement is relative to the starting location.